This is going to be a real quick video about what happens to glycerol and fatty acids when we oxidize fat, and amino acids when we break down those amino acids, what happens to them in the energy pathways. So we've done this, right? We did carbohydrates are broken down into glucose, glucose to pyruvate, pyruvate to acetyl-CoA, which can go into the TCA cycle, and then the hydrogen ions get sent to the electron transport chain to yield a lot of energy. Next we're going to talk about glycerol and fatty acids, which are what fat breaks down into. Glycerol can go to pyruvate, and fatty acids can go to acetyl-CoA. And then we'll talk about amino acids. Amino acids are unique in the fact that some amino acids can be turned to pyruvate, some can be turned into acetyl-CoA, and some are used directly in the TCA cycle. So when we're talking about glycerol and fatty acids, I've just mentioned, glycerol can be converted to glucose or pyruvate. So we're going to talk about the pyruvate aspect of it. In the process of fatty acid oxidation, fatty acids are taken apart 2 carbons at a time. So if you remember, acetyl-CoA are 2 carbon long molecules. They have 2 carbons. So when we break down fatty acids, and most fatty acids that we eat are about 18 carbons long, that can produce a lot of acetyl-CoA, right? This will be one, right? This will be another one. This can be another one. So an 18 carbon fatty acid molecule can yield about 7 acetyl-CoAs, which is why we get more calories. That's the measurement of energy. That's why we get more calories from fat than we do from carbs and protein, because we can make a lot more acetyl-CoA, and then that can enter into the TCA cycle and produce a lot of energy. So fatty acids, like I just said, I should have had this slide up there, but when we break down fat or triglycerides, we break it into glycerol and fatty acids. So the glycerol can be turned into pyruvate, and then of course pyruvate to acetyl-CoA. Acetyl-CoA will enter the TCA cycle. Fatty acids, on the other hand, they get chopped off 2 carbon molecules at a time. So we can make 7 acetyl-CoA from an 18 carbon, a 16 carbon fatty acid. So we get a lot of acetyl-CoA when we break down fatty acids. And that's, I kind of got ahead of myself, but that's why fat has more calories per gram than carbs and protein. Fat is 9 calories per gram, where carbs and protein are 4 calories per gram. So for the amino acid pathways, first, before they can enter the energy pathway, they have to be deaminated, which means they're going to remove the nitrogen from there. And then some of the amino acids can be turned into pyruvate, and then some other ones can be turned into acetyl-CoA, and still other ones can enter the TCA cycle directly. If you have some amino acids that are turned into pyruvate, pyruvate can be turned back into glucose. So we can use amino acids to make glucose. But if you have converted your amino acids to acetyl-CoA, they can also be used in the TCA cycle, or they could be stored as fat. So this diagram shows you most amino acids can be converted to pyruvate, but some can go directly to acetyl-CoA, while others enter the TCA cycle directly. So the TCA cycle is the common metabolic pathway between all of the macronutrients. Whether you're a carb, a fat, or a protein, you most likely are once you're broken down to your smallest portion, you're going to enter the TCA cycle in one way or another. Here is the TCA cycle diagram from the textbook, and it also has a good diagram for the electron transport chain.